This is Lesson 3 of our Year 10 probability unit. Today we're going to talk about the addition law and introduce the concept of mutually exclusive. The addition law, there's a rule which we need to learn, which says the probability of A union B equals the probability of A plus the probability of B minus the intersection of A and B. And the question is, why is that the rule? Well, let's try and explain it. If we look at a Venn diagram of A and B, if A union B means everything in A and B, if you have a look, if I add up all the bits that make A, which is that section, and all the bits that make up B, which is that section, you'll see that this section has been counted twice. So that's why we say A, probability of A plus probability of B, take away the intersection because it's been counted twice. The term mutually exclusive means that two events don't have anything in common. So the Venn diagram demonstrates this the best. Here's circle A, here's circle B, and if there's no overlap between the two circles, then we say they are mutually exclusive, which means there's no intersection, or the probability of A intersecting B is equal to 0. Let's have a look at an example. Here's our same example of the parents born overseas and they're fluent in the second language. So we've already done this Venn diagram a few times. Here we're asked to find the probability B union L, which means everything in B and L, which, if you look at the Venn diagram, it's just the shaded areas in that second one. So we can simply add up the numbers there and we get 6 plus 4 plus 3 equals 13 out of 24. Or we could have done it by using the addition law. Probability being B is 10 out of 24 because there's 10 things in B. Probability of L is 7 out of 24, but this section has been counted twice, so we subtract it once. So 10 plus 7 take 4 is 13 out of 24. Same answer, two different approaches. Example 2. There's the addition law. We're asked to use the addition law to complete this table. So the first one, we're told the probability of A is 0.3, probability of B is 0.4, the intersection is 0.1. If we follow the addition law to find out the probability of A union B, then we go 0.3 plus 0.4, take away 0.1, which would be 0.6. In this case, we're given the answer. So on the rule we'd put 0.75 there. We don't know what the probability of A is. Probability of B is 0.3 and that's 0.25. So to work out probability of A, I've got to take those things over the other side. So I need to take away 0.3 from both sides and I'll need to add 0.25 to both sides. So net effect is we end up that this probability of A must be equal to 0.7 because that plus that minus that has to equal that. In the last one, probability of A and B are 0.5 and 0.4. We're told A union B is 0.9. Following the rule, 0.9 equals 0.5 plus 0.4 minus what? Well, they add up to 0.9, so it has to be 0. What can you say about the events A and B in part C? Well, if there's no intersection, as it's showing here, then they are mutually exclusive. So, things we need to remember from this. There's the rule, it's called the addition law. Probability of A union B equals probability of A plus the probability of B, take away the intersection of A and B. And if there's no intersection, we say the probability of A union B is 0. They're mutually exclusive. These are the questions you need to do from this topic. You'll notice there's some from 8C and some from 8B. Good luck. Thank you.